In section 10.3, we're going to be looking at operations with radicals. Our first example, we're combining like radicals. Now you can kind of think of this the same as combining like terms. So imagine if this was 6x plus 9x, those would be like terms, and we could add 6x and 9x together and we'd get 15x. In this case, we have 6 times the square root of 11 plus 9 times the square root of 11. Now, since they both have the square root of 11, these are like radicals, meaning you can combine them. But watch what happens. We add our coefficients. You can think of these as coefficients. 6 plus 9, which is 15. Now, the radicals stay the same because we're combining. We have 6 square roots of 11, and we have 9 square roots of 11. And when we combine them, we have a total of 15 square roots of 11. So when we're adding, this stays the same because we're simply counting how many of these we have. We have 15 square roots of 11. Now in example 2, we're simplifying to combine like radicals. Sometimes we have to simplify first. 5 times the square root of 3 plus the square root of 12. Now 5 times the square root of 3 is simplified all the way. But the square root of 12, we can simplify that more. And what we have is the square root of 12 can be broken into 4 times 3. So when we add these together, we first have to factor out 4, which is a perfect square. So when we factor it out, it's going to be a 2. So this would actually be 2, the 2 comes out, times the square root of 3. So that 4, the square root of 4 comes out as a 2. Now, we have like radicals. So we have 5 square roots of 3 plus 2 square roots of 3 for a total of 7 square roots of 3. In our third example, we're going to be multiplying radical expressions. We have the square root of 10 times the sum of the square root of 6 and 3. Now, if you're thinking this looks like a distributive problem, you're right, and we are going to distribute. We're going to distribute the square root of 10 to the square root of 6 and to the 3. When we do that, we get square root of 10 times the square root of 6, which is the square root of 60, plus 3 times the square root of 10 is 3 times the square root of 10. Now, we have to look and think, are there any perfect squares in 60 that we can break this apart? Well, sometimes that's hard to know right off the bat just by looking at it. But what you can do is you can factor it. Just take any factor. So let's take 6 times 10. That's pretty obvious. And from 6 times 10, you can break these apart as 2 times 3 and 2 times 5. Now, the key to look for are matches. So we have 2 factors of 2. So when we do that, we know that when we have 2 of them, 2 squared, we can factor one of them out from underneath the radical sign. But I'll write it out this way. 4 times, and we have 3 times 5 left over, which is 15, plus 3 times the square root of 10. Don't forget about that. Now we can factor out the square root of 4, and it becomes 2 times the square root of 15 plus 3 times the square root of 10. And that's the final answer. Our fourth example deals with something called conjugates. Conjugates are the result of factoring the difference of 2 squares. So when you have a square root plus a square root times the same square root minus the same square root, there's an easy way to do this. Instead of foiling this out and distributing the square root of 7 to both terms and the square root of 3 to both terms, we can simply take the square root of 7 squared minus the square root of 3 squared. Now, if you're squaring a square root, those two things cancel each other out. So you're left with 7 minus 3, which equals 4. So keep a lookout for conjugates because they are easier to deal with. There's some special rules that you can use to finish problems like this one. Number 5, we're going to rationalize this denominator. This denominator would be tough to rationalize if we weren't going to use the conjugate to rationalize it. So notice that this problem is 10 divided by the square root of 7 minus the square root of 2. Now we cannot have radical signs in the denominator of a fraction and call that fraction simplified. In order to simplify it, we need to get rid of the radical signs. And the way to do this is to simply multiply the numerator and the denominator by the conjugate. So we have square root of 7 plus the square root of 2. All we do is we take the opposite operation with the same two radicals, and then we'll go from there. We need to put the same thing up top. So now let's do the numerator real quick. We're going to distribute the 10 to both of these, and we get 10 times the square root of 7 plus, well, right now let's do this. Let's just write it this way for right now. Square root of 7 plus the square root of 2 over. When we FOILed this all out, we would end up getting the square root of 7 squared minus the square root of 2 squared. And remember, I just said that a squared square root they cancel each other out. So we're left with 7 minus 2, which is 5. So we're going to put 5 in our denominator. Now, here's the reason I didn't distribute this already. These two have common factors that we can cancel. 10 has two factors, 2 times 5, so we can cancel a factor of 5 out of that and this 5 out, and we're left with a 2. Now let's go ahead and distribute our 2 to the square root of 7 and the square root of 2. So our answer is 2 times the square root of 7 plus 2 times the square root of 2.